Hi. So I'm Anil,
Hold
and
on.
I'm
Okay,
here
go
with.
ahead. Go for it.
Oh, we're good.
Sorry.
Are we
Go
good?
ahead.
I'm Anil, and I'm here with Khaled, and we're going to be talking to you today about AMIE, a conversational diagnostic AI. So this is a paper out of Google that had a huge list of authors and other people that helped make this happen. So some of those people are all listed on this slide. Essentially, the problem here is surrounding the medical interview. So the medical interview has been termed the most powerful, sensitive, versatile instrument available to the physician. So, when you go to the doctor and they start to talk to you and ask you about what's wrong, this is what we're talking about. And so LLMs really excel at diagnosis. We've seen if all the information is already there. So there's been a lot of papers from our group showing this, also with GPT-4. But the question we had here is, what if the agent itself needs to gather this information? So the information's not all there at the present, and that's not all fed in the context, but the agent actually needs to extract this information from a patient. And so this is about so much more than just acquiring information. This is also about, establishing rapport, communicating preferences of the patient, things like that. So our question here that we wanted to answer is, can LLMs conduct effective diagnostic dialogue intelligently and compassionately acquiring information under uncertainty? So first, before we get into the actual methods behind our modeling, we first want to talk about some evaluation and how we did that. So our general philosophy here was we want to test AMIE the same way that clinical communication skills are assessed in humans. And so the format that we were talking about here is something called the Objective Structured Clinical Examination, or OSCE for short. So this is something that medical students will be very familiar with. Essentially, it's a practical format where they have standardized actors who are trained to portray a specific patient based on scenarios that they're given. And these patient actors are interacting with the students, where the student has to do this kind of interviewing of the patient actor in order to, figure out their diagnosis as well as, being evaluated on a predefined checklist for that particular scenario. And so we created a set with our partners. We created 149 of these scenarios. So these were from many different locations. So we had a set of 60 scenarios from Canada, 14 scenarios from the UK, as well as 75 scenarios from India. And for all these scenarios, which spanned, many different specialties as well, we had 20 patient actors from Canada and India, as well as 20 PCPs from Canada and India, go and perform these scenarios and these OSCE conversations. So the study design was basically as follows. Sorry. So we had this simulated patient, which basically consists of a patient actor trained on one particular scenario pack. And their role is basically to embody that particular scenario. These scenarios have information, not just about the patient's symptoms and their history, but also specifically like what information they're allowed to disclose, what information they offer up at first, and, maybe even information that they decide not to disclose at all. And so these simulated patients will be interacting with either AMIE, which is our model, or a PCP, and they do this in a randomized blinded sequence. So they don't actually know whether they're talking to the model or the PCP. In fact, they don't actually know that they might be talking to an AI model. But they do have one conversation with one of those two OSCE agents, and then later on they'll have a conversation with the other OSCE agent. So after they have this conversation, and so this is done over, a synchronous text chat, we have that consultation transcript come out. The patient actor will then, look at the conversation and reflect on how they felt about that conversation and answer, various questions regarding things like, the empathy and, the relationship fostering skills of the thing that they talk to. And similarly, the OSCE agent, so that's the doctor or the model, will also have a questionnaire to answer. Their questionnaire will actually deal with what their differential diagnosis was for that patient. Do they recommend that the patient has any follow-up, escalation, things like that. And so then this consultation transcript comes out, and an actual specialist physician, so someone who specializes in whatever that scenario pack was about, will actually look at the consultation transcript as well as the questionnaire provided by the OSCE agent, and they'll basically evaluate the performance of the OSCE agent in this consultation. And so, they're going to be looking at things like the accuracy of the differential diagnosis, as well as, some of their other recommendations around investigations and follow-up and things like that. And they'll also be evaluating, some of those clinical communication skills that the patient actor was also looking at. So, the first kind of thing that we looked at here was just differential diagnosis accuracy. And here we were using top K accuracy. So essentially, the OSCE agents, either AMIE or the PCP, would provide, what are the top 10 most likely diagnoses for this given patient. And across all scenarios, we see that basically AMIE is able to achieve a higher top K accuracy for, any value of K. So whether you look at their number one most likely diagnosis or their full list of 10, they were more likely to have the ground truth diagnosis in their differential. And so we looked at this with respect to like the single ground truth answer. We also looked at this with respect to an accepted differential list. So these scenarios also had like a list of not necessarily the ground truth diagnosis, but other differentials which maybe could be accepted for this. Okay. And so we also looked at this across different specialties. So we see, for all these specialties, we see AMIE is surpassing the PCP in performance, and that holds. Next, we also wanted to, rather than needing a specialist to, evaluate every single diagnosis, we wanted to be able to do this internally, like through our own model. So for each diagnosis on the differential diagnosis, we asked MedPom2, which is a different LLM that we have. We asked this following prompt, basically to decide whether the predicted diagnosis was the same or, adequately equivalent to the true diagnosis. And we found that, first of all, our auto-validation ratings were roughly aligned with specialist ratings, which is good. And essentially, this decided that we were able to, use this as a kind of proxy for specialist ratings. And, one reason for this that we wanted to do this is that, it's kind of insufficient in medicine to just look at like string matching. So, for example, like things like COPD and chronic obstructive pulmonary disease, like if someone wrote COPD, that should be marked as right. But if we were just to look at a simple string matching, we would see some errors there. But the other benefit of this is that we can quickly ablate some different factors for a diagnosis. So I'll talk about that in the next slide. So one of the questions we had was, sure, AMIE is doing better than the PCPs, but, why is that? So is AMIE actually acquiring information better than the PCPs, or is it just able to, given the information it does acquire, it's able to use that information to come up with a better differential list? So the way we tested this is essentially we took the full AMIE consult and we also took the full PCP consult with the simulated patient. And we gave those both to AMIE and just asked AMIE to produce its differential diagnosis from those two different conversations. And we actually see the performance for these two settings are actually very, very similar, which tells us that, the performance gain we see from AMIE is not really from it acquiring better, information in the conversations, but really it's that second step of, just generating that differential list. That being said, it is able to perform equivalently to, the PCP at acquiring information, which in itself, I think, is an interesting result. So the other thing we want to look at is basically like, how do these conversations differ? And so, we can see that the patient actor and, regardless of whether AMIE or the PCP is interviewing them, kind of acts the same in terms of their number of words that they're writing out in their responses. But the OSCE agent does act very differently, right? So AMIE is a lot more verbose. You can see, in this middle panel, you can see that the number of words that the LLM is producing in its conversations is much, much higher than the number of words the PCP is producing. Um, Okay, so we wanted to look at basically the efficiency of information gathering. So, does the PCP or AMIE kind of get enough information to produce its diagnosis earlier, or does it follow a similar progression? And so here what we did is we took these different conversations and just took the first, T number of turns, and basically fed that into the model and saw, what was the differential diagnosis accuracy for those number of turns. And you can see like it's pretty remarkable that, even within like the first 10 turns of the conversation, they really start to very quickly, be able to make this diagnosis. And I think the longer conversations go, the less, there's kind of reduced benefit of, continuing the conversation longer. But these trends look very similar between AMIE and the PCP. So that's for, diagnostic accuracy. We also, obviously wanted to look at all of these different, more qualitative axes. So here we have, patient actor ratings for, many of these different axes. Overall, AMIE is winning on 24 out of 26 of these, and the ones where it doesn't win on, it is, non-inferior. It's just not significant, but it does, in those cases, it actually does seem higher without being significant. And so, things like, assessing the medical condition, explaining condition and treatment, appearing honest and trustworthy, all these things, we're seeing that the patient actors actually believed that, AMIE did a better job at this than the physicians that they were talking to. And then similarly, when the specialists looked at these conversations and as well as the, post questionnaires from the OSCE agents, they also rated AMIE as winning in a majority of these, so 28 out of the 32 axes. And so, again, like things like the quality of their history taking, their appropriateness of their differential diagnoses, management plan, all these things, AMIE is kind of surpassing the PCPs according to the specialists as well. Okay. So I'll pass it up to Khaled to talk more about, how did we actually make this model happen?
Awesome. Yeah. Thank you so much, Anil. Um, yeah, Anil just presented a lot of really cool results. But yeah, how did we develop AMIE to have such high quality conversations in a diagnostic setting? So an initial starting point that makes sense is to kind of, create a data mixture of medical tasks, and you choose your favorite base LLM. In our case, that was PaLM 2. It could be another base LLM, and you fine tune on these medical tasks. So the medical tasks we had were the first three here: medical reasoning, long form medical QA, and medical summarization. These are similar to the tasks that were used in MedPalm 2. They're mainly to give the base model a bit more of a medical specialization. But in addition to these tasks, we also added real-world dialogues. So these real-world dialogues consisted of around 100,000 audio transcripts of conversations that happened in clinical settings between a primary care physician or a doctor, clinician, and a patient. And there might also have been a nurse or a caregiver in the room as well. Um, so these are transcribed real-world dialogues. And so we appended that to give the base LLM the conversational abilities and for history taking. And so when we, previous slide, please. So when we actually trained our favorite base LLM on these tasks, we found that, AMIE V0 wasn't actually, having high quality conversations. We were curious why that was. And when we looked into the real world dialogues, we found that, there were two main reasons. The first reason is that even though we had a lot of real world dialogues, there still wasn't that large of a coverage for different medical conditions. So I think we had around like 168 medical conditions in those real world dialogues. there are definitely a lot more medical conditions out there. So coverage was one challenge. The second challenge with real world dialogues is that they're inherently noisy. So when we're talking like we are right now, there are awkward utterances like and like also just awkward pauses. I might be moving my hands to describe something to the patient or be pointing implicitly referring to something, and all that information is lost and isn't transcribed properly. So when you fine tune, your model on some noisy data, it's not too surprising that the outputs are also going to be noisy. So in order to improve on these two challenges, we were inspired by the upcoming literature about synthetic data using these LLMs, these highly capable LLMs to create high quality synthetic data. And so that's what we added to our data mixture. Yeah, and so how exactly did we create these simulated dialogues? Next slide, please. So the way we created the simulated dialogues is this multi-agent self-play simulated dialogue generator. In this multi-agent framework, we have a patient agent, a doctor agent, a moderator, and a critic agent. I'll go over each of these step by step. Next slide, please. Okay, so let's start with how we have the patient agent, how we instruct it. The most important thing is one of the critical parts is this vignette generator, right? So if we want an LLM to act like a patient, we need to give it some context on, what are the patient's symptoms, what's the condition, what's the social history, surgical history, all the relevant background needed in order for a patient to have a conversation with a doctor. So this vignette generator, the way it creates the vignettes or the patient backgrounds is we first scraped, we used existing scrapes of the internet of medical conditions. So there are existing scrapes that have tens of thousands of medical conditions. And then we take this medical condition and we use web search tools to try and find, corresponding symptoms and surgical histories and social histories and all the relevant information with that given condition. And so we use the web search, and then we also use MedPalm 2 to actually just refine those web searches to make them a bit higher quality. And so that's what the vignette generator does. It actually solves the first issue of coverage because now we can scale up to tens of thousands of medical conditions. So that's the vignette generator. Next slide, please. Now we kind of need to, given this vignette of a patient, we need to create the simulated dialogue. So we do this using these three agents, the patient agent, doctor agent, and moderator. All these agents are actually played by AMIE, and they're instructed with unique instructions. So the patient agent, we instruct, we give it all the relevant background information, the vignette, and we ask it to answer any questions from the doctor in an honest way, and to ask the doctor any questions they may have. And then we instruct the doctor to kind of get as much information as they need from the patient in order to be confident with giving a differential diagnosis and management plan. And so then now when we have these two agents instructed in this way, we just always initialize the conversation with, for example, the doctor saying, "Hey, how can I help you today?" And then we go back and forth between the doctor agent and the patient agent, where every response is being appended to a conversation history that stays in the context of the agents. And so they go back and forth. And the moderator's job is to detect the end of the conversation. So the moderator is instructed to, if the doctor agent gave the differential diagnosis and management plan, and the patient agent is satisfied and doesn't have any more questions, or if one of the agents kind of initiated a farewell, the moderator agent kind of flags, "Hey, this is the end of the conversation." And then we get the end result, which is the simulated dialogue. Now, in order, when we first started off with doing this, we realized that it's pretty challenging to kind of have this multi-turn data going with multiple agents because the agent might maybe ask too many questions, the doctor agent might ask too many questions, or the patient agent might have some repetitive things they're saying about themselves. So in order to improve the quality of those conversations, we also add the fourth agent, which is the critic. So this critic here, we give it is instructed to analyze the conversation that happened and to look at specific axes like did the doctor ask the appropriate questions? Is the diagnosis accurate at the end? And other axes that we instruct the critic. And so then the critic gives feedback to the doctor agent. And then the doctor agent, then we kind of reset. We have now another, back and forth between the patient and the doctor, except now this time the doctor's instructions are conditioned on the critic's feedback. So this is the inner self-play loop where we use this kind of critic feedback and back and forth in order to create the simulated dialogues. And that's what kind of solves the second challenge of producing higher quality conversations. And so now when we have the simulated dialogues, which is added to our data mixture, we fine-tune AMIE. And when we fine-tune AMIE on the simulated dialogues, now AMIE is better at being a doctor agent and a patient agent. And so we also have this outer self-play loop. And this outer self-play loop means that every time we fine-tune AMIE, we have a new version of AMIE that's better. That means we can produce even higher quality simulated dialogues. So we have this self-improvement loop going on, which is what we refer to as the outer self-play loop. Now, the last part is that at inference, so after we train AMIE, we also have this reasoning chain. So we kind of break things up into three different subtasks. So when AMIE is having a conversation with a patient, instead of just giving a response right away to what it thinks is the best response, we give it these three tasks. The first task is analyze the context. So look at what was said so far in the conversation, summarize, all the symptoms and information that were stated so far, and then think about what additional information is needed. And then given the output of that task, we then ask AMIE to generate an appropriate response, whether that's a follow-up question or whether that's giving the differential diagnosis or the management plan. And then the third subtask here is just refine the response, things like make sure the formatting is nice and clean and also make sure to be empathetic and things like that. So that's what we do at inference time after AMIE's train. Yeah, next slide, please. Yeah, so this is just I guess maybe yeah, this is an animation that visualizes the concepts that I just went over. So we have the patient simulator that creates synthetic conversations. The critic is giving feedback to improve the quality of those conversations. We then use those simulated conversations to fine-tune AMIE. And after each iteration, the performance across these different axes improves. And we do this for a few iterations to get AMIE to be trained. Yeah. So there are definitely a lot of important limitations about this study. So one that we want to emphasize is that we designed this study as a kind of virtual text-based OSCE. So this is because this is the way we naturally interact with AI systems or LLMs, right? Over synchronous text. But it's also not normal clinical practice. So the primary care physicians aren't trained in that setting. So that might be an important reason for why they weren't performing as strongly as they might have in different settings. And also we didn't really explore, would the primary care physicians do a lot better if they also had access to AMIE's responses? And so these assistive effects weren't taken into consideration in our study. And while we did have a very broad evaluation criteria, uh, there are still important axes that we didn't consider, and of course scenarios. So our patient actors were limited to around 149 uh, different patients, and so that wasn't exhaustive. So we didn't explore rare diseases and presentations. So or different, the way patients might act, they could act adversarially, and we didn't comprehensively look at all these conditions. So these are important limitations to keep in mind when looking at our results. But yeah, we're very excited about what we have done so far with AMIE. We think it's a really important step towards providing healthcare, high quality healthcare that's affordable to many folks, and we're excited to keep improving on these systems. But yeah, this is just a high level overview, and we're very happy to have a discussion about it. Thank you.
Great. Thank you so much, Anil and Khaled. This is really awesome. So we're going to dive straight into a couple of student questions, and then we'll have sort of a longer form conversation between us after that point. So to go first into a couple of student questions, one student asks, first of all, why start with Palm 2 as the initial model? Is there anything in particular that you like? Did you try other base models? How did the performance compare?
I can take that one, I guess. Like yeah, when we started this project, that was the kind of model everyone was using at Google. And I think, now if we were to start again, they obviously have, Gemini has come out, so maybe that would change. But that was like kind of the state of the art at the time we started working on this.
Yeah, and I'd also like to add to that um, kind of I think a lot of these capabilities with kind of having the inner self play work, you need the LLM to really be good at instruction following for this to happen. So we looked at what was the most capable LLM that was available to us at the time. But AMIE isn't just like a single model snapshot. It's a system that we're iterating on every day.
Got it. Another student question is there any degree of rankings among the patient scenarios in terms of which are more complex to solve than others? And have you broken down the sort of relative performance against PCPs by the different scenarios and how difficult they are?
So we haven't really like ranked all the scenarios in terms of difficulty. We did do a couple of like ablations in terms of, one by specialty, and we do see like I think I showed earlier that we did have like different performances across different specialties. Like here, I think the internal medicine might have been a little bit tougher, for example. And actually, like some of these cases, so like for internal medicine, for example, like those cases were actually all from the UK, and it could be like regional as well. So there could be differences between, the Canadian cases and the Indian cases, which we do also present in the paper. But we didn't go, I guess, like much deeper than that in terms of looking at difficulty beyond between cases.
Got it. I mean, so aside from, really formalized results, did you build any intuition for this over the course of just like working with the model and playing with it that, if it had some really strange scenario, it was more difficult for it to work. And if it had some, much more common one, it was like going to get it exactly right all the time? Or not?
Yeah,
Curious.
I would say like intuition wise, like definitely like when we threw like really, you know, bread and butter cases, like common presentations, especially like one that we used a lot was like with appendicitis, and you have the, lower right sided pain. It's like it sees that thing, it's the obvious common presentation, and it gets it. Whereas you could confuse it by giving it more uncommon presentations of diseases.
Got it. Makes sense.
Or sorry, I'm gonna
Go
jump
ahead, Michael.
just because I'm curious as well how Khaled will respond to this. But related to like some of his past work, right, with like the robustness and like kind of like spurious correlations kind of thing, right? Like, did you see that there were cases where, or like how do you think about like like AMIE sort of generalizing or like supporting, let's say, different patient populations, whether you want to stratify that by like I don't know, disease related or not disease related, right? Like, did AMIE perform worse, let's say, on a certain patient demographic? And how do you imagine like sort of like fixing or accounting for like these potential differences across like stratifications?
Yeah, it's a great question. I think this is so we had some explorations that we didn't include in this study, and essentially one of the advantages of the synthetic data generator is that you can explore some of these things at scale and kind of just change the prompts of for example, to the patient agent and ask the patient to act a certain way and see how the performance changes. And this is something that we're currently doing now. So that's why we wasn't included in this initial study, but we're starting to look more into these robustness questions. And we did see that, definitely when you ask the patient to act in a weird way, for example, it would be important, just to make sure for equity reasons that uh, if the patient, maybe the English isn't perfect, right? That AMIE is still able to respond appropriately, or if they're, let's say there's someone that are very very verbose and they read a lot of things online and they want to like fact check everything they've read online, right? How does AMIE do in that situation? So we see that right, depending on how adversarial you want to make the patient, the performance could decrease. But I think for this initial study, we wanted to have everything behave normally to just first see like, is this possible? And we're currently looking a bit more deeper into those robustness questions. Yeah, I think the simulated environment is great to also play around with those scenarios.
Cool, thanks.
So another question for you, Khaled. How do you see long context models potentially improving or not improving the performance of these? Is this something where we would want to be able to have either much longer form conversations or ingest, lots of patient history? Do you think you'd see the performance in these studies sort of meaningfully change, or is this actually not as meaningful? And like in these scenarios, it just doesn't matter that much?
Yeah, that's a great point. I think we were definitely believers that the long context capabilities of this next, version of models is going to help us here. As you're alluding to, you know, other than just giving more context on the patient, you can imagine scenarios like there might be certain guidelines, for example, that are going to be relevant for giving the diagnosis or the management plan, and so you can just given those kind of condition-specific guidelines into the context, and so you can have more grounding. And I think it's a very important limitation of AMIE now is that we want to make sure that its responses are grounded and these medical guidelines. So I think long context can help there. Another scenario is this is just like a single visit study, but if you can imagine naturally we go to the doctor multiple times, so multiple visits, and so you can keep appending those conversations over time, and that can help as well. Anil, I don't know if you also wanted to add anything, but yeah.
No, like totally agree with what you said.
Got it. Makes sense. So another question. In the synthetic data generation loop, do you do quality filtering and other sorts of things to make sure that the, doctor and patient agents are aligned with the simulated ones? Or are you sort of just counting on the overall outer loop to solve all the problems and it just kind of converges to the right thing in expectation anyways?
Uh,
You don't take it? All
the question was about the inner self-play or the outer self-play? Sorry.
The question was about essentially just, you're generating all the simulated dialogue in order to feed into it. Do you do any additional kind of filtering on that to make sure that it's matching the distribution of the real world dialogue?
Yeah, I think there's definitely a lot more room for us to improve over there. We did take advantage of the auto eval. So actually, Anil, if you go back to the slide that shows the entire, yeah. So this auto evaluator, you know, gives you a score on some of the axes that we instructed it to look at, and so if we got low scores on some of the quality coming out of those simulated dialogues, we wouldn't include them. Anil, were there other things we did specifically for this?
Yeah, I mean, I think the point, I think like it wasn't so we didn't have like a like formal like quality check like module in there. I think that is like a great idea. And we did have like a lot of like, we had clinicians look at some of these simulated dialogues as they were coming out and use like feedback from that to modify instructions to the critic and the agents, right? And I think a lot of that informed how those instructions came out. Um, and ultimately, I think like the main quality check here was the critic, but there's definitely room for like additional oversight in that sense that wasn't like heavily used. But really we relied on the critic and also this audio evaluation and like kind of manual looking over like these conversations to inform all of this.
Gotcha. And I guess so maybe I missed this part, but was the critic sort of trained specifically, or how was the critic, I guess, trained, I guess, as much as you're, I guess, allowed to say? Um, was there sort of like initially some sort of like initial like gold standard like human annotation there? Because I guess what I'm trying to get at is like the critic I could see as like kind of like a reward model in some sense, right? Where you're using like this reward model to be like, okay, like rating the, I guess, quality of, let's say, the doc, in this case, like the doctor agent, sort of how the doctor agent performs. And if you're able to sort of like have that be like a good reward model, then yeah, you could sort of like have this like really nice like inner self-play loop. But I'm curious, like there needs to be some like initial sort of information injection. And so like was like the critic sort of, yeah, how, I guess, like how did you get like a good critic? Um,
So as a quick answer, like all the four agents were played by Amy. So the critic itself was we never trained to do well on the critic task.
uh,
But we as AMIE is improving its ability to have high quality conversations, uh, then that also implicitly improves the critic's ability to give feedback on different conversations. And so the critic mainly was through prompt engineering, essentially the instructions and like Anil was saying, like in this collaborative way with a clinician, how to give you, at the end of the day, you kind of want like a list of things that like determine what's a high quality conversation in this setting.
mhm.
Uh, so it is also actually one of our limitations is that translating, what is a high quality diagnostic conversation uh, isn't an easy task in itself, and maybe we didn't get it perfectly correct, right? We did our best like collaborating with these clinicians, but essentially, just to answer your question with the critic, it mainly came down to prompt engineering, telling it what defines a good conversation, and then yeah, it is in some ways like a reward model, except that it's outputting like the feedback in text form, and then that's being used in the doctor's conditioning the doctor for the next round. Um,
I see. So all of this like quote unquote like, I guess, like self-play, or I guess like the improvement is via just like kind of like text as a modality. There's no like updating with like the weights in some sense.
Yeah, not until the outer loop. Um, the inner
Gotcha.
loop is just through text.
Okay.
yeah,
Cool.
it's like implicitly human in the loop in a way, like because maybe you're wondering like, okay, like how's this self-improvement happening? It's like the human in the loop part is like implicitly through those instructions. and and then yeah.
Gotcha. So I guess kind of related to maybe some of like the constitutional AI stuff.
Yes, yeah. I think there is strong connections there. Yeah.
Cool. Um,
A couple more student questions. One student asks, how are privacy and HIPAA concerns integrated in the model? Are there real patient conversations used to train or update, and if so, like, are they anonymized?
Yeah, so the real world dialogue is included and yeah, it's anonymized and like compliant with everything.
Cool. And another student asks about, so if I understood the chart correctly earlier, it was about on different specialties of medicine, but still comparing against PCPs as opposed to comparing against specialists. Have you also done comparisons against specialists, or is this sort of just the comparison generally against PCPs?
So this comparison was just entirely against PCPs. And in fact, we had specialists do kind of the rating of whether it was correct or not. I think it is an interesting question to see, to also benchmark against specialists here, but we didn't do that in this study.
Yeah,
Makes
we
sense.
had the patient actors do the evaluation on the patient relevant axes. So things like how honest was Amy perceived, or the empathy and the rapport building, everything related to the patient was evaluated by the patient actor. And then everything related to like, needing clinical knowledge to do the evaluation was evaluated by the specialists.
Got it.
cool.
So I have
Yeah.
a question personally I wanted to ask, which is not a student question, so it's a me question, which is essentially about, how would you imagine putting these kinds of models into practice? Where on the one hand, I can see a lot of risk that you put this model out and it, makes mistakes, it like causes real harm. But then on the other hand, you have, so much demand for medical care that's not being met and incredible costs associated with it. But if you can really create more preventative care, like that seems like a really big win. So I'm curious as, two people that really play with these models and I'm sure think about this, how do you think about those trade-offs?
Yeah, and I'll give it a quick first take, but uh, it, it it's a question we've been, as a team really thinking about a lot, because it is, I think I can say this confidently about everyone on the team. Like, it is our dream to get, tools like this out there in a safe way, and provide healthcare to at a very low cost, and uh, I think so we're mainly focused on like the art of the possible and really pushing the boundaries here, like from the research side of things. And our belief generally, or our philosophy, is that we're gonna try and do as much as we can with uh, advancing these capabilities, and having rigorous evaluations, uh, and we're hoping that, like, when you compound enough of these evaluations and enough of these studies, uh, then we would be, in quotes, allowed to share this technology with a wider audience. But like everything with healthcare, like uh, you need very comprehensive evaluation, and that's what we're focused on as a team. So we have, different projects that range from like pure studies, and then pure like improving capabilities, and they um, we're hoping the collection of these projects would lead to that. But uh, yeah, it's a big challenge. Anil, did you want to add it?
Yeah. I think totally what you're saying about like we want this work to be kind of like the leading edge, showing, what is possible, and following up on this, showing ideally we'd be able to start showing this with clinician partners in the real world in some settings, but obviously those need to be much more controlled, and like the goal is not to, this is a research system, right? Like the goal is not to just let it loose and like see what happens. Like all of those studies that follow also need to be like very, um well, like a lot of oversight and things like that.
I guess so on the topic of, I guess like patient, or sorry, not patient, but just like quality. This is pretty interesting. So I pulled up I don't know if there's a way to show this, but like I pulled up I was looking at the blog, and there's like this like plot at the very near the bottom, which is like accuracy of like clinician. I don't know exactly what task this is, but basically like there's unassisted clinician, and there's like clinician with AMIE and like clinician with search and AMIE only. Um, is this like ringing a bell or?
Yeah, so that study, so we had like a kind of related study also using AMIE, but that was on the NEGM CPC cases. And there we were just we weren't really assessing conversational capabilities. We were just assessing, diagnostic accuracy on these like really challenging case studies. And so right, so there the study did show like um basically the clinicians were able to interact with AMIE in formulating their differentials, and that, significantly improved their performance. And we also saw that, AMIE alone performed quite well on this task. But that was not done in this like OSCE setting. So it's a little bit of a different study.
Gotcha. Okay. Um, Yeah, I'm curious. So I hate to ask like a difficult question, but like on this plot, it seems like I was just curious about this, right? Like, so the AMIE model itself seems to actually perform better than clinician assisted by AMIE. And I was curious, like, or if you have like any thoughts on like why that could be the case. Maybe it's like the diagnosis here is like pretty hard to do, or yeah, curious about this.
Yeah, I mean these are like really so we're not the thing we're showing right now, but like for that NEGM study, like those were again like really like challenging cases where the ground truth diagnosis was, often something very like esoteric. And I think it's reasonable to say that like um clinicians, their first instinct is probably not to like go for the most complicated, the most like esoteric answer, whereas that might be more something that like an LLM would be inclined to do. So I don't think you can really extrapolate those results to like general diagnosis, but at least like in that particular study, that's what we saw.
Gotcha. Okay, thanks.
One question that's been fairly persistent on YouTube is, have you thought about using these techniques for other, dialogue-based workflows? I mean, medical diagnoses are, just one of them, but there are other kinds of, cases. Frankly, a lot of the economy is the service sector of like talk to someone and they tell you something, and that repeat, vice versa. So, and I'm just curious if you guys thought at all about applying these techniques to those methods. Which one do you think would be most appropriate? If not, why not?
Yeah, actually the a lot of the inner self-play work was inspired by a paper that was looking at this in a negotiation setting. So we uh, I think you're 100% right here that like what we're doing with these ingredients of creating synthetic dialogues and having a critic, the only things that would need to be changed really is the vignette generator. So how do you get that like initial seed point for one of the agents to have a conversation? It's kind of like this inner self play is kind of like taking the vignette, which is like a summarized, condensed paragraph of information and pulling it out into a conversation. And so I think the main thing that would need to change is this, replacing the vignette generator for whatever domain you're in to get that background information to create a conversation. And then, of course, like the critic instructions and then the specific prompt engineering that goes there. And it can be applied to many different domains. But for us personally, we're very passionate about the health setting, and I think there's still a lot to do in that regime, so we're gonna be focusing there. Yeah.
Actually, could you talk, this is my own curiosity, could you talk a little bit more about the vignette generator and kind of any of the tricks that you might have learned about how to generate like good vignettes that encourage diverse and interesting conversations between the patients and the doctors?
I guess like we can talk about like how we made the vignettes, right? Like, I think we mentioned we used like a search tool there, and here we have however many conditions that we're pulled, and we basically are searching for, very different aspects of these conditions. So, the demographics, the symptoms of these conditions, like what are typical assessment and management of these conditions, and trying to get a kind of broad understanding of those conditions, and all of that information can be compiled and to form, diverse patient vignettes. And so, for each condition, we had, multiple, patients meant to kind of exemplify a range of possible presentations of, that particular condition as well, based on all that information that was pulled.
I see. Sorry. So let me make sure I understood what you just said. So you're saying that you're building a lot of the vignettes out of search data first, and then so just I didn't quite catch this. Are you using LLMs as well to like go and write the full kind of vignette and polish it up to be put in, or is it really just built out of like this database and like mixing and matching some pieces?
No, so an LLM is actually like also generating these vignettes based on that information that is taken from search.
And after the Q&A slide, I actually have a snapshot from the paper on, right
Yeah.
there.
Right.
These are
Got it. That is very helpful. Thank you.
yeah.
Okay, one more question, and then maybe I'll ask if Michael has any, and then we can wrap it up. Any thoughts on sort of multimodalities for the future? Like if you had additional modality information, vision information to understand patient discomfort or videos or whatnot, do you think you would get big lifts in quality?
Yeah, definitely. That's something of interest, and a very natural way to evolve AMIE is by continuing to improve its capabilities, including ingesting different forms of modalities. Uh, I think with things like video and audio, you can also get a lot of information about mental health and or if you're taking pictures of maybe a skin condition or uh, that could help a lot. Now, of course, you can do a lot with just text because all those modalities can be described in text, and then you can give that to AMIE, like any modality report, like a chest X-ray report. You can put the report in AMIE like right now, but I think there's always information lost there. But then if having a video interaction, the audio, your tone, the way you're speaking, can have a lot of information about your uh, other subfields in medicine, like maybe psychiatry, and those are things we actually didn't look into in this study, like things like psychiatry, and they can particularly help for that as well. And also the human computer interaction part is a big open question as well.
Yeah, I guess maybe like one last question to follow up on that is related to, let's say, the span of like things that you could, I guess, like help with these kinds of like automated assistants in some way. Like, did you ever consider, I guess, I guess AMIE is like patient facing, but like, did you ever consider like in some ways you could use the critic to help like doctors uh in terms of like, I don't know, doctors interfacing or having better, I guess, like more aligned patients or conversations with their patients. So like, do you ever consider sort of like an AMIE or like a chatbot thing for like doctor guys quality or care assistance? Yeah.
Yeah, it's a beautiful idea. I think, we agree that I think AMIE can have a lot of assistive effects or an educational aspect. We're thinking of those things, but I'm not sure how much I could share at this point. But like, it is a great point, and we do believe that it can have a lot of educational benefits for clinicians as well. Yeah.
Cool. Awesome. Thank you.
All right. Thank you guys so much. This is fantastic. So with that, I think that concludes episode, what is this, 95 of our seminar. And we'll be back next week. And thanks again so much, Khaled and Anil. It was a great talk.
Yeah,
Thank you so
thanks.
much.
This is great.
Thank you.
Let's turn off the stream. And